All right, in our next circuit, what we are going to do is take advantage of something called PWM, which is pulse width modulation, and that's going to allow us to not just turn the LED on or off, but to set its brightness somewhere in between. And we're also going to make our first reading of something, and in this case, it's going to be an analog read of a component known as a potentiometer. So let's take a look at how we make that happen. First of all, we've put our potentiometer here on our breadboard, and we did take advantage of that rotate function I showed you earlier. And it has three basic legs, one terminal on one side and a second on the other, and one called the wiper in the middle, and that's sort of the read leg. So we're going to take that reading leg and we're going to attach it to analog 0, which is what's going to be capable of seeing the value that it is. Now, I've hooked this leg, terminal 2, up to 5 volts, and I've connected terminal 1 to ground, but as you can see in my note, you could have flip-flopped that and it would have worked all the same. I still have my LED, in this case it's green, and I've got it hooked up to digital pin 6, and there's a reason why I've chosen pin 6 in this case. It's because it has that little squiggly mark called a tilde next to it, which indicates that it is PWM available, which means it's not just high or low. I can write from 0 to 255, which is somewhere in between. So that's how the wiring diagram is going to work for this code. Now let's go take a look at the code itself. Now, in the top of our list, you'll see that I've created two byte variables. One is called LED pin, and it is indicating that I've plugged it into 6. The other is called the pot pin, and I've plugged it into A0, keeping in mind that you can name your variables anything that you'd like. You might notice here that I switched from an integer to a byte, and that just encoding sometimes saves you some space because the numbers we're using are very small. Bytes work better than ints, which are a little bit larger. Now in void setup, I'm going to initialize my hardware. In this case, I'm going to turn on my serial monitor. I'm also going to set my pin mode of the LED as an output. And even though I don't have to do this, I'm going to, just for the sake of you seeing it, I'm going to set the pin mode of my pot pin to an input. Now, in the void loop, I am going to create an integer value called the pot value, and I'm going to set it equal to the analog read of my pot pin. And this is going to go in and take the raw reading right off of the potentiometer, which, when you're reading in analog, can be anywhere from 0 to 1023. Next, I'm going to convert that reading into something that I can write to my LED. And I'm going to set another variable called the LED value to the mapped value. Now, map is a function that will take the values of one variable and convert them into a second set of values that you can use in another variable. So in this case, I am going to map the pot value, which starts at 0 and goes to 1023, and I am going to convert those from 0 to 255. I'm going to make a third mapped value just for the sake of you understanding how this works, and I'm going to call it brightness. And I'm going to map the pot value from 0 to 1023 to 0 to 100. And I'm creating that just so you understand that for a potentiometer, if it's set to 0, the brightness of my LED is going to basically be 0%. And if I set it to 1023, it's going to be 100%. Now I'm going to bring in my serial monitor and I'm going to print those values just so that I can visualize them as the code starts to run. So you'll see here that I've got a sort of series of print calls. Anything in quotes is something called a string, and that is going to literally be printed to my serial monitor. Anything not in quotes is going to basically call the value of the variable that I'm discussing. So you'll see, for example, serial.print raw value is then going to be followed by serial.print pot value. So in this case, I'm going to be able to push that value directly next to its label. And you'll also see that I included an ln after my print call. That ln says line, and it's essentially going to be like hitting the return or enter button on your keyboard, and that's going to carry the next value down so that it separates it a little bit. So you'll follow through and see my print calls. This little bit here is actually an insertion into the original footage that I had taken, and I had seen a little bit of an error, actually quite a large error, when we were editing. So on line 22 here, you'll see, compared to the old footage, that it now reads as an analog write as opposed to a digital write. And that's super important because remember what we said earlier, we're using pulse width modulation, which is PWM, because we don't want to turn the LED on or off. We want to set it to some value in between 0 and 255. Now we got that from line 14 earlier where we mapped the potentiometer value to those 0 and 255 numbers. So now what we'll do on line 22 is we will analog write that LED pin the corresponding LED value as we read the potentiometer. And then on line 23, we'll finish up with a quick 1-second delay so that we can visualize it in the serial monitor. So now if we start the simulation and we open up the serial monitor, you should be able to see the raw mapped and brightness values. Now if I come in here and I begin to toggle the potentiometer, you'll see that we do get the LED responding with different brightnesses, which is exactly what we are looking for. The higher the potentiometer number, the greater the brightness of the LED. Alright, so you might have guessed what I was going to ask you to do next, and that's going to be to add another LED and another potentiometer. And I want you to try to control individual LEDs using individual potentiometers and get them to brighten or darken based on their value. Now this is going to lead into next week's challenge, which is going to be to control an RGB LED which has 4 total legs that we can set to any color of the rainbow. But before we can get there, I want to see if you can take multiple components and keep them separate. And just to take a quick peek into the code, in case some of you were wondering how you add components, keep in mind you don't want to repeat yourself too much, but you do need to change names and make sure you're indicating where you're plugging in the things that you are on the Arduino. So this is a little bit of a sample of how you can get this dual LED to work. I'm not going to walk through it this way, so if you want to go ahead and pause the video and see if you could do this for yourself, and then potentially add a third LED to the mix, that's going to set you up nicely for next week's challenge, which is going to be to control an RGB LED. So I hope you had a good time this week with Hack the Hollow in virtual mode here. And I'm looking forward to bringing in other types of projects in the future, including some actual online Raspberry Pi stuff as well. So, stay calm, keep coding, and, I hope everybody stays healthy and safe. See you next week, guys.